Welcome to Elevate 2021, and I'm John Strano, and this session is Profile and Trace, catching the app in the act. I am the sole author of the content of this presentation, and Appian makes no warranty of any kind, either express or implied, including but not limited to the implied warranties of merchantability, fitness for a particular purpose, or non-infringement. Appian assumes no responsibility for errors or omissions, which are solely mine. So the session agenda, what's the content here? What are we going to be talking about? First, when is debug just not enough? And when we do talk about trace, what are the different views of your application that are available? And we'll talk about the optional approaches for tracing your application's execution. And we'll talk about the 3 different timers and their types and what their features are. And the beauty of tracing, profiling your application. And then we'll talk about real-world framework considerations for reuse and enterprise implementation. So yes, I'm John Strano. Here's my boilerplate. I've been using PowerBuilder for a while, since version 1.0b. I've been an instructor, an systems architect, a programmer, and, well, the full spectrum of what you can do with PowerBuilder since 1990-91. I am working with Intertech Consulting, and we are the oldest and largest consulting firm specializing in PowerBuilder tech in North America. We focus on architecture, consulting, education, programming, and project management. We can take care of your enterprise solution needs. Give us a call. All right, so when is debug just not enough? Oh, my origin story, Lordy. My background for systems education, I only had 1 semester of Pascal as an undergrad. And not just Pascal, but Waterloo Pascal. Not UCSD, but Waterloo Pascal. And aside from that, and 5 jumpstart sessions in PowerBuilder back in 1990 from my good friend Bob. Thank you, Bob. I am self-taught as a programmer. And so what I learned, when I learned that there was this thing called a debugger in PowerBuilder, I said, what? What? You mean I don't have to post entries to an external log file? I can dynamically step through each line of code, see what the variable values are? Well, I was just floored in the most pleasant way possible. But the observer, in this case the debugger, potentially disturbs an observed system just by the act of observation. So what do we do? What do we do about that? You know, at times we'll want to get something closer to a system or production test rather than a unit test. And let's face it, when you're in the debugger, it is solely a unit test, not something that's going to show you how your application exists in the wild. And that's something that we can do with profile and tracing, or pretty near. So yes, enter the profile trace capabilities of PowerBuilder. So there are 3 kinds of views for the trace that you'll generate, and we'll talk about that profiling in just a bit. But the 3 views of your profiling are class, routine, and trace. So the class view, it gives you some very interesting metrics and 3 flavors therein. It'll give you the numbers. It'll give you a perspective on the source. And it'll give you perspective for data visualization. And then the routine type of profiling will concentrate on the different methods. It is a somewhat older term to use routines, and it's not very specific as far as functions versus routines. But yes, for the method calls, here's the perspective and running up the tally for the different metrics for that, the key performance indicators. And then my favorite, frankly, the trace. All sorts of stuff is available, and I really do gravitate towards this particular view of the generated trace from your application. So, what are the different ways to be able to generate the trace? The options are the command line, running it from the PowerBuilder IDE's graphic user interface, or the developer-defined user-controlled window, frankly, the Powerscript, the Powerscripted option. And this Powerscripted option is developer-defined by you and developer-controlled as far as its granularity, or lack thereof. So let's talk about the command line approach. You can generate an external trace profile file by just executing your executable on the command line with the pb-debug switch. What are the pros and cons of this approach? It can be invoked for any PowerBuilder developed executable anywhere, anytime. The runtime takes care of that file generation for you, so that's a plus. It also generates the DBG file as a text file. Any text editor can read it, although you may want to make sure you use a text editor that can handle fairly large text files. One of the cons is that the trace file has to be for the entire run of your application, and of course that means that it's potentially large, unwieldy, unreadable, and is that impractical? For all but the smallest of applications, I would venture that yes, this might be viewed as a showstopper. And plus, there's no timing information. When was the absolute start time? What was the relative time of execution for each method, for each call to a system function? There is the IDE GUI approach, alternatively. This is the Profile tab in the System Options for PowerBuilder's development environment. What are the pros and cons of this? Seeming ease of configuration, a nice GUI there for you to be able to choose the options. The timing information in the generated profile trace file is there. Negative? It also has to generate the trace file for the entire run of your application. And yes, we've already spoken, it's potentially impractical because of the size of that generated file. And difficult to successfully generate the trace file from the GUI within the PowerBuilder IDE. Anecdotally from the field, some folks have had quite a difficult time in being able to generate this from the system options. And just so we can see what we're talking about, let me navigate to that. So here we are with the PowerBuilder IDE, and to get to profile trace definition, let's go up to the Tools menu item. Click on System Options and the Profiling tab page. And we can choose to enable tracing. Now remember, this will be for the entire run of your application. You'll be able to define what your output trace file name will be, and for the different multiple potential blocks of the trace, you can enforce a label for each run, and then which kind of timer you're going to have: clock, process, or thread. And then all the trace activities that are possible to include in the generated profile trace file. You can choose to have all of them or just one. That was the IDE GUI approach. Next, we'll talk about the developer-defined window approach. Simply put, you're going to use the Powerscripted capabilities to emulate your own version of that graphic user interface, that window. It'll be your own window class. Pros and cons, seeming ease of configuration for you and the user. It can be similar to the GUI of the Profiling tab in the System Options, as close or as much of a departure as you wish. The timing information is available. And it can be as granular as you want, since you can provide it to be your users who initiate and control when that profiling begins and when it stops. Or is this a minus instead of a plus, in that it is user initiated and you're trying to catch the application in the act of some anomalous behavior, perhaps waiting for the user to be able to initiate the trace? They just will miss that event at that instant. So it's arguable whether or not this is going to give you the level of control that you desire and need. Now, this is actually implemented using the scripted approach. In other words, in that you're providing this GUI to your user, arguably it is using the developer scripted approach, but I'll be talking about a little bit more sophisticated, elegant, and arguably powerful way to approach this. And yeah, it's the users who need to narrow it down, and will they be able to catch the application in the act in time to be able to generate that trace file. All right, let's go ahead and look at what I'm talking about. So here we have one of the PowerBuilder code example applications. What I'm going to do is open up the About window, and to it we see that I've added a command button that opens up the window of type main that is the profiler window that I have created. So here we have most of the options, if not all of them, from the System Options Profiling tab page. I'm going to go ahead and select the output file to which I'll write. I'll choose the type of timer. In this case, it's going to be clock. And I'll go ahead and select all of the options that are available here as far as activity types to capture. And I'll go ahead and begin profiling. And now I'll go ahead and come back to the application, click OK, close the About window, and I'll just interact a bit with the tree view here and cause it to refresh, just so I can capture some little bit of activity for example's sake. I'll go ahead and come back to the profiler window, and I'll click End Profiling and close. I'll go ahead and close the PowerBuilder application. Back to the IDE, I'll open up the new interface window and the tool tab page, and I'll select Profiling Trace View and click OK. And PowerBuilder needs to know which target file the classes that were profiled are listed in. This will tell it where the libraries are. And here we have that captured. And we see the refresh of the tree view happening. Selection changed. And we can expand that and see some tree view items being created and destroyed, as well as some execution of the embedded business method. Let's go ahead and go up to the options and the preferences. And what I want to do is to implement some of the additional viewing options. So what I will do is now click on Show Argument List and Return Types for the routines. I'll also say that I want to show the line information and the system routines when and if they're called. I will not choose to aggregate calls. This will actually give a trace profile of multiple calls to the same functions or methods, but aggregate them, consolidate them into one entry in the displayed file. Let me go ahead and click Apply. And we'll see that the view has refreshed. I'll go ahead and expand Selection Changed, OF Refresh Info, and we'll see there's a whole lot of stuff here being displayed. Line numbers, very helpful. We'll see what's being executed and how long it takes. Some of these timings are negligible, down to hundredths of a second, and others are significant enough to be able to be displayed with that format. And the next approach that we will talk about is the pure Powerscript approach. It's one preferred by myself in that I believe it provides a better level of control by the developer. Yes, it's nice in some scenarios to have the user be able to define when the trace begins and ends, but again, we're trying to catch the application in the act, so to speak, of anomalous behavior. So again, this preferential treatment is just my own personal preference. Pros and cons of this approach is that it can be as, yes, granular as the developer wishes it to be. The timing information is available in the output. However, there is one big Achilles heel to this, is if the application abnormally ends, the trace end is never invoked, and the PBP file is not generated. And I'll talk about some functional considerations closer to the end of this presentation about how we can actually accommodate that and be able to tree the animal, close the perimeter, and get it up the tree at the very least before it's captured. So we'll talk about functional considerations after I give you a look-see at the actual Powerscript itself. So here we have that profiler window of type main, and what I'm going to do is to open up the Powerscript for this begin profiling command button. And perhaps it was misleading. At the heart of the window that you saw in the demonstration is a pure Powerscript approach, albeit in our case a hybrid one, where the user defines when the tracing begins and when it ends. Here, with a pure Powerscript approach, you can define when that tracing begins and ends. And again, perhaps closing the perimeter on the animal and get it up the tree in preparation for capturing it. Again, we want to catch our application in the act of committing its anomalous behavior. So you, the developer, can choose what type of timer, whether it's going to be clock, process, or thread, or no timer, very rarely used. And then the trace file is going to be opened. And then there are all the options available for the configuration of the output. It can be embedded SQL, it can be garbage collection, line detail, routines signatures, as well as errors of different types, etc., etc. And again, this is going to be a pure Powerscript approach, and I recommend you consider this strongly. It has served me well, especially with my most recent project. All right, more on the pure Powerscript approach, especially its functional considerations. You need to configure this for the field. How is it going to be configured? Its attributes, values. How are you going to implement those attributes, values at runtime? And how are you going to store them on the user's workstation? They can be hard-coded in the script. That's not desirable, but it is possible. They can be stored in an IDE file. And although I'm not a fan of the registry, many enterprise solutions do still depend upon the registry, so that's quite possible. Or an IDE equivalent, storing those configuration values in a database. The PBP file, or the PowerBuilder profile file, has special constraints, requirements. You may need to create an artificial sandbox. That is, especially if your pibbles are stored in subdirectories and subdirectories of subdirectories, especially if you're using certain versions of source code control. The pibbles will need to be copied to a single pot where they have a flat storage structure in the file system. And the PBT, the PowerBuilder target, and pibbles need to be in the same directory as the PBP file. And if the PBP file has been generated in the field by executables, yeah, the PBD files must be in that same directory. So you have very much a lab bench scenario. And of course, the PBDs, these have to be the same version on the bench that generated the PBP file in the field. If not, you'll see this error, that the visual model just could not be built because the resources are mismatched. So let's review the timers and their types. I know we've spoken to them in a cursory fashion up to this point, but let's talk about the ramifications of each of these choices. The clock, which is the default, if you don't specify a timer type, it will utilize clock. It measures the absolute time with reference to an external activity. In other words, perhaps the computer's startup time, the workstation startup time. It's measured in microseconds, unless, of course, your CPU offers some higher granularity than microseconds. The process timer. It's an arguably more accurate measurement of how long a process is taking to execute, but it excludes the time taken by any other running processes. However, it is a lower resolution than the clock timer. Now the thread timer. It's a more accurate measurement of how long a thread is taking to execute and excludes the time taken by any other running threads. And you always use this for distributed applications because it ignores things like host server startup time. This information, yes, it would be misleading to say the least. However, it is also a lower resolution than the clock timer, so there is a trade-off. And yeah, love this, love this, love this. The fact that you can catch the execution time of almost every line of code in seconds, up to hundredths of a second, is quite illuminating as far as your application's performance. What do I mean? Let's say your application is crashing, and you just don't know what is causing it or which lines of code, let alone which method, is actually being executed at this point in time. And remember the output logs that we all had to depend upon? Now we have an additional type of dog with which to hunt, in addition to output logs. Output logs have not lost their relevance, but you can't put in a log entry for every single line of code. The profiling will time those lines of code's execution. So this means that performance reviews are possible line by line. You can identify where your solution's thin ice is in the code. What do I mean by that? You can cross-reference it with external monitoring resources and give a Nielsen rating, so to speak, for your inter-tier interaction. In other words, let's say that you use SolarWinds DPA, performance monitoring, and you have certain slow performance in your PowerScript code execution. You can go over to the actual database monitoring tool to see if there was something going on at the trace log start time. Here, in this one particular instance for a recent customer, we had noticed that there was an almost half-second delay in doing something as simple as assigning a data window object to the data object property. Now, why was this? We have been contemplating putting a network monitor in place for this. Why might this be happening? Conjecture is, at this point in time, this is very fresh, is that perhaps we're using PBDs across a wide area network, and perhaps in that PBDs are not necessarily cached, they're more or less pulled in on demand. We're considering taking those data window objects that are causing these kinds of delays and putting them instead into the EXE so that they're always there available and don't depend on potential delays that are being caused by long throws and accesses across a network. And let's say that you had anomalous behavior in your database and not just your network. You can start to correlate and cross-reference with database monitoring tools. So multi-tier cross-referencing becomes possible, especially when you have the ability to monitor your PowerScript performance down to the microsecond. Okay, let's talk about profile tracing within the context of framework considerations. Here's where it becomes potentially powerful and thereby exciting. How can you integrate your PowerBuilder profile tracing into a framework? So let's talk about service-based architecture. Let's suppose that you have a dedicated component, a non-visual object, for PowerBuilder tracing. It is an instance property of your global NVO that's retaining global values at runtime. Let's also presuppose that in your INI file, you're going to store two sets of stuff. One is an array of class names for trace begin, and an array of class names for trace end. This way, you can modify, edit your user's INI file as you become suspicious of certain classes that might be causing anomalous behavior like abnormal end, your application abends, and you've started to narrow down which classes may be involved. You'll have these two arrays, these two comma-separated values in your INI file for which classes you want to have a trace begin and end. So here's a sample INI file. Let's say that the section is for profile trace. And you have a flag that says, yes, we want to profile trace this application at runtime. And what's the location of the PBP file at runtime? Where's the target location where it will be stored? But then we have two lists of comma-separated values. One for where the trace begins and one where the trace ends. Notice that we have a wish for having the trace to begin and end for wlogin, where it opens and closes. But let's say that we wish another set, parenthetical set of begin and end for tracing to start at a print 01 window and to end at the third print window. So we have that ostensibly a trace spanning 3 window classes instances at runtime. And yes, we could have that same or analogous capability for user objects. In other words, we could have the begin and end and the open close or constructor destructors. Let's examine this a little bit more. Okay, moving on with this framework proposal. Let's say that our constructor of our trace, dedicated trace component, or some initialization method of it, we load up an instance data store with the two sets of comma-separated values from our INI file. We put them in a data store. That's an instance of our trace, instance property of our trace component. This data store will have a data window object that has two columns. It has a class name trace begin column and a class name trace end column. All right? We're actually a prep cook right now. We're putting everything in a row so that our chef can actually put these ingredients together. We also have in the PB trace NVO a global flag, a Boolean, for trace is in process. And in the ancestor of our framework, in the constructor or open event of these ancestor classes, if this .class name is in the trace begin data store array equivalent column, we find out if it is by utilizing find. This is the beauty of PowerBuilder. We have a data window. We can actually search the equivalent of an array using the find method to see if the current class, the descendant instance that's opening, does it have one of our trace begin classes? And then, if indeed a trace is in process, we check the Boolean value of that flag, and only then, if it is not in process, then we issue a trace open. In other words, only if trace in process is false do we then open and start a new trace. Otherwise, we just piggyback on the pre-existing trace in process. And we set the in process to true. And in our ancestor classes, visual, non-visual, we put in the destructor and the close methods, we put that if this class name in the data store array equivalent, we use the find again to see if this is one of the classes where we want our trace process to end. And we close the file. And we set the trace process to false. Okay, so for what scenario have we provided with this framework proposal? Let's come back to the INI file slide. And let's look at the begin trace classes and the end trace classes. The use case is that your QA folks, your beta testers, perhaps even your production users are experiencing anomalous behavior, either overt errors or degradation of performance. What you do is gather the PBP files from these folks, put them on your bench, and analyze them. And from this analysis, you begin to suspect that you can begin to narrow the field. And you know better and better with each iteration which classes are involved. And without having to recompile, re-QA, or redeploy your application, you simply have their INI file edited, either in place or you send them an updated INI file that has a different set of begin trace classes and end trace classes until you finally identify the portion of the application that is truly, let's not call it at fault, but is involved with what will eventually become a code change. And the whole point is that you provided for this procedure, this process in your framework. Please do participate in the community out at community.appian.com. The community is stronger for your participation. And please do take advantage of these resources. And with those framework considerations, we come to the end of our presentation. We will stick around to answer any remaining questions that you may have.